Hello! So today what we're going to do is we're going to work on another toy conversion. We're going to hack one of these crawlers, this bear sort of remotely controlled crawler. It has 3 motors in it. One that drives the right wheel on treads, one that drives the left, and then another one that drives the up and down. And this one is actually ideal for hacking. It's going to be super easy because everything just unplugs, which is really nice. And this particular guy, you can see, actually this one is not working, so this one makes it a perfect one to hack. Something seems to be broken within this controller. So you can see the basic idea. This is going to be able to raise and lower this additional motor. It will raise and lower the treads. And then of course I would be able to drive it left and right. And then by pushing both the sticks. So what we're going to do is we're going to get rid of this completely. And we're going to try to hook it up to an Arduino Uno, and then using one of these motor driver boards, which will drive 4 DC motors, we're going to use it to run the 3 motors and hopefully make this thing remote or autonomous. I think I'll probably start off by making it remote with a Bluetooth controller like this one and or an infrared remote control. And to get started, it's really simple. And we're going to go ahead and just basically get rid of this. We don't need this anymore. And we've got 3 motors, like I said, a left, right, and the center one here, this red-black wire, is going to be for the center motor. I'm just going to unplug these, like so. And what I want to do is I need to do a little bit of playing around to figure out how to make this thing go. I think the easiest thing to do is to get some of these male headers, and I think I'll just start with one. I'll just grab the one here on the right. I have no idea the polarity, how it's supposed to be. I'm simply going to put these into here, and I think I'll go ahead and get this hooked up onto this board, and then we'll begin to play with it and see if we can make at least one motor go. So let me pause it, set things up, and I'll be right back. Okay, so I've done a couple things and wrote a small piece of code. One thing I had to do is hook up this battery pack, which I did by attaching the red wire here, the positive wire, over to the one that's labeled positive. Okay, screwed it in, and the ground goes here. And then I've taken this jumper, okay, that we had plugged into this one motor here on the right, and I attached it to 2 pins here that correspond to motor 1. Alright, so that's all kind of hooked up. The reason I had to do this is my computer doesn't have enough power coming through the USB cable to run these motors when there's so much gearing in it. It has too much resistance, too much drag. So it needs some sort of external power supply. And the code, really simple. I've included the library necessary to run this particular device. Okay, I have taken motor 1 here and created it. I called it right motor or R motor. I have launched the serial port, even though I'm not actually going to use it yet. Then here in the loop, what I've done is I've set the speed to the maximum. 255 is the maximum speed. You go from 0 to 255. We can play with that. And then I tell it to run forward for 1,000 milliseconds or 1 second. And then I tell it to release the motor, essentially to stop it. And then I put it in an infinite loop. This while true is going to get stuck here forever. So normally loops go round and around and around, but in this case I want to run the motor for 1 second and stop. So if I load it up, you can see, I'm going to lift this up so it doesn't drive away, that in fact if I tell it to go forward, well, that actually went in reverse. So that's a super easy fix. I'm just going to flip this around. So that way my command forward will actually be a forward. So we'll load this up again. And there you go. It went forward for 1 second. So I think what I'm going to do is I'm going to add the other motors and get it defined. I'll be right back with you. Hold on a second. Okay, so I hooked up another motor. Let's see how it works. I did exactly what I did with the other one. I simply took a male-to-male jumper here, I attached it to motor 2 position, and I then in code added a motor 2. I called it left motor. And then down here in the loop, what I've done is I literally just copy and pasted these lines right here, paste it right down here, and I changed it from R to L, from right to the left. So it's going to run the right motor for 1 second and then run the left motor for 1 second. If we load it up, we will see, hopefully it does what it's supposed to. And the right motor, oh, actually I have the same problem I did the other time. The reverse, the left motor was going reverse. So I'm just going to unplug it, twist the wire. Let's load it again. And hopefully in this case we'll get the right motor and the left motor. Right motor. And the left motor. Perfect. Okay. So let me hook up the next motor and I'll be back with you in just a moment. Okay, so I've hooked up this next motor, and in this case I've created, I called it the lift motor. And down here you can see I just copy and pasted this block, and I went ahead and put in lift motor. And actually what I'm going to do, I'm going to go ahead and temporarily comment this out. Okay, I did that by the way with a control slash, a forward slash, so you can comment out a block. And we'll watch it. And this is kind of a strange one because you can see that when I run this, it runs in a loop. So there really is no up or down. It just rotates. So let me just set this. Actually, we're going to run this for like 5 seconds. You'll see what I mean. We can flip the directions, but I don't know which is up and which is down because this shaft is going to rotate continuously around. And it's just going to go through all the moves. So I think I'm going to arbitrarily decide one is up and one is down. There's really no reason to flip the polarity. I don't know which is right or wrong since it just goes in a loop all the way around and around. So we'll just make it so you can adjust it one way or the other, and it will be for whatever purpose you want at that moment. Alright, so let me pause this and get a little bit more done, and I'll see you in a second. Okay, so I've done a lot playing around with the code and kind of organized things a little bit. This all remains the same. I haven't changed that at all. Big changes in the loop because what I ended up doing was creating these functions, okay? So I created a forward function where I took the left and the right motor, put them together in a single function. So I set the speed and then I tell them both to go forward, so the right motor and the left forward, so the whole robot should go forward. And then I created a function called reverse, the exact same thing, set the speed, and I tell both the right and the left to go backwards. Then there's a turn right function which should make the right motor go forward and the left one, oh, so that's actually a turn left. Let me think, if this one's going forward and this one is going in reverse, yeah, oh no, that's right, okay. So it'll turn right, turn left. And then I have a stop bot. Notice it turns off all of them. Okay, it turns off the right, the left, and the lift. And then I have these two things I called L up for lift up and lift down. And again, keep in mind they go 360 degrees in rotation, so it's kind of arbitrary, but it allows you to switch the direction. So one way would go one way, one would go the other. So I'm going to load this up, and we should see this robot. Oh, let me go back to the loop. Show you what I've done. So what I've done is I then called each of those individual functions that I just created with a 1 second delay. So it tells it to go forward and then it waits for a second. So during that whole time that it's waiting for a second, it's going forward. Then it switches directions and it goes for a whole second. It turns right for a whole second. It turns left for a whole second. It stops the entire thing, so everything shuts down. Then it does both the ups and the downs, and then it shuts off all the motors once again, and finally we ended up in this infinite loop, so it goes no further. So let's load it up. It's going to be a little messy here because everything's just kind of laying around on the bench. We should see it go forward, reverse. Oh, that was a turn left. I gotta switch that. Okay, that time I had to go up for 3 seconds and then down for 1 second. And that first was a turn left, so that actually is incorrect. This should be a left. which I guess makes sense. And this is a right. So let's run that again. So we should see it turn in, we want to see it turn that way first. We want to see it turn right first. Yes, turn right first. Okay, so we'll see if we do a better job this time. It's going to go forward, reverse, turn right, there we go, and then left. Okay, so now I think it's time to try to get all this stuff bundled up onto a package so we can make it portable and not drag this around. So let me get that set up and I'll be right back with you. Okay, so I've got these parts that I've designed and printed on a 3D printer that will allow it to sort of sit up here and we can work with it and put everything in a nice organized fashion. I'm going to push this back a little bit. Okay, so you should have these 3 pieces and some different screws, 1/4 inch and 3/8 inch that you should be able to use. And ultimately what has to happen, and I'll probably pause this from time to time, this piece here gets screwed on like so. Okay, so what we're going to do is I'm going to take a 3/8 inch screw. Actually a 3/8 or a 1/4 works just fine. And I'm going to put that in there because actually this 3/8 is almost too long. And this is going to go like so. Okay, and I'm actually not going to, well, maybe I will make you watch me do this one. See how it actually sticks out a little far? That's okay. You can use either the 3/8 or the 1/4 for that purpose. And let me put this one in there, like so. Okay. And then this piece gets attached on the back. These 4 holes here are going to line up with these 4 holes here. So once again, I'm going to put this guy in here, get it started like so, and get that lined up. I'm going to keep that one loose until I get the other one started, and I'll tighten everything up, make sure it lines up. And another. Okay, and lastly another one. Okay, I'm actually going to go ahead and pause this, tighten all these screws, and I'll be right back with you. Okay, so now it's time to attach the motherboard and stuff. For safety reasons and keeping things from shorting out, I'm going to remove one of these batteries to break the circuit, and I'm going to unplug my USB cable. Okay. And then you will have to separate these boards again, like so. Hopefully we won't unplug anything. And this guy is going to get mounted on here like this with 4 of these 1/4 inch screws. So I'm going to go ahead, I'll start one, but then I'm going to pause it because I'm getting close to the end of the time. So let me screw these in, I'll be right back with you. Okay, so I've got the board attached here, and now what I need to do is, I actually just disconnected this. I found a little inconvenient to try to swing it around, so I've temporarily unscrewed this. And now I'm going to take this guy and kind of work it around, get it back lined up so that this lines up here. Make sure my pins line up, seat that in there like that. And this entire assembly just sits right on top like so. So now it's pretty good, and this battery pack is ultimately going to sit right here. And I think what I'm going to do is I'm going to go ahead and reattach these wires. I'll be right back with you. I'll pause it while that happens. Okay, so I think we've got a pretty nice platform here. It's all hooked up, ready to go. So I'm going to end this video, and I'll see you guys shortly on the next video.